Welcome to the 59th episode of AI Talks with Chris and Nita.
Great to be here.
Today we're taking a deep dive into how computer programs really get started. Specifically, that very first stage, lexical analysis or scanning. Forget the complex stuff for now. We're talking about the absolute first look a computer takes at the code you write.
That's right. You write your program, and it's basically just a long string of characters to the computer initially.
Just text.
Exactly. And before anything else can happen, the machine needs to chop that string up into, well, meaningful pieces. It's sort of like reading a sentence. You don't see just letters, you see words.
Okay, and these meaningful pieces, these chunks, are what we call tokens, right?
Yeah.
So what exactly makes a sequence of characters a token?
A token is one of the fundamental building blocks in the grammar of a programming language. It's a sequence of characters that actually mean something specific in that language.
And programming languages, they only have a limited set of these token types.
Yeah, a finite set that the computer's trained, essentially, to recognize.
Okay, let's break those down. What's the first category? Maybe keywords.
Good place to start. Keywords are the language's reserved words. They have very specific, unchangeable meanings. They really define the structure of the language.
So the compiler really hangs its hat on these.
Totally. They're unambiguous signals about what the code is trying to do.
Can you give us some examples people might recognize, like from C?
Sure. In C, you've got words like if, else, for, void. Those tell the computer about decisions, loops, function types, that sort of thing.
And you absolutely cannot use these for your own names, like variable names.
Nope, strictly forbidden. They're reserved. C, for instance, has exactly 32 of them. That's it.
32.
Okay.
Next up, we have identifiers. Now, these are the names we programmers make up.
Precisely. Identifiers are the labels you choose for things like variables or functions or arrays the elements you're creating in your program.
Are there rules for making them?
Yes, definitely. In C, for example, an identifier has to start with a letter or an underscore. And after that first character, it can have letters, digits, and underscores. Oh, and C is case sensitive.
Ah, right. So my variable is totally different from my variable.
Exactly. Count and count are two separate identifiers as far as C is concerned. And of course, they can't be the same as any of those 32 keywords.
Got it. Then we have constants, fixed values.
Yes, also called literals sometimes. These are values that just don't change when the program is running. Fixed things.
Like numbers.
Right. C has different kinds, whole numbers, integers. Numbers with decimal points, those are floating points. Even single characters like A, or sequences of characters, which we call strings, like hello.
Makes sense. Our fourth type, operators. These seem like the action symbols.
That's a good way to think of them. Operators are the symbols that tell the computer to actually perform an action on data.
Like math.
Yeah, arithmetic is a big one, plus, minus, multiply, divide. But also comparisons, like checking if one value is, say, greater than another, or logical stuff like and or.
Okay. And finally, the fifth category, special symbols. These sound structural.
They absolutely are. Think of them as the punctuation of the code. They define the grammatical structure very strictly.
Examples.
In C, the semicolon is crucial. It marks the end of a statement. The comma A often separates things like function arguments or values. Curly braces block off sections of code.
Ah, like for functions or loops.
Right. And square brackets are typically used with arrays. These symbols aren't optional. They're essential delimiters and markers for the compiler to follow the structure.
Okay, let me see if I've got this. The lexical analyzer, the scanner, it reads our source code, character by character, and it bundles these characters into a stream of tokens. Keywords, identifiers, constants, operators, and special symbols. Is that the gist?
That is the core of it, yeah. This stream of tokens is then passed on to the next stages of compilation, like parsing, where the computer starts to figure out the actual meaning and logic based on how these tokens are arranged.
So it's not always simple, just grabbing characters.
Well, not always trivial. The analyzer often uses patterns, regular expressions usually, and sometimes it actually needs to peek ahead a character or two.
Look ahead. Why?
To be sure what token it's seeing. Think about operators like plus versus plus plus in C. It needs to see the second plus to know it's the increment operator, not just addition.
Ah, okay. So it seems like even the most complex software starts with this fundamental step, just breaking the raw code down into these basic units, these tokens.
It really does.
Understanding this first pass gives you, I think, a much clearer picture of how computers actually start to interpret our instructions.
And what's interesting is how this technical process sort of mirrors something fundamental about how we communicate.
How so?
Well, think about it. We use words and punctuation, they're kind of our tokens, right? To build up and convey meaning.
Words, commas, periods.
Yeah. The basic principle of breaking down complexity into fundamental, understandable units. It's not really so different when you think about it that way, is it? Consider how even in our own communication, we rely on fundamental tokens, words, and punctuation to convey meaning. The process isn't so different, is it?